Hello everyone. Now we are going to discuss the random variate generate, and in this random variate generate we are going to see the technique called as acceptance rejection technique. The acceptance rejection technique is used for checking whether the random variate and the random numbers used can be accepted or rejected. Previously in the previous sessions we have seen in the random number generations whether the random numbers being generated can be accepted or not, which has been done by the hypothesis, that is the null hypothesis. So there may be some cases where the random numbers can be accepted and some cases where the random numbers can be rejected. So based on this we have random variate generator, and based on this random variate generator the numbers being used can be accepted or not, can be used or checked by the technique called as acceptance rejection technique. And the acceptance rejection technique is having the algorithm, and the algorithm is being explained in the next slide. Here you can see the heading, that is acceptance rejection technique, and here we have in this acceptance rejection technique three steps, that is step 1, step 2 and step 3. As of now you can see in this, that is step 2 is being subdivided into step 2a and step 2b. I'll be discussing why we have change this step 2a and 2b. But basically in acceptance rejection technique we have three steps: step 1, step 2 and step 3. Step 1 is for using or generating the random number, step 2 is for the comparison, and step 3 is for checking whether the random variate is accepted or rejected, and the random variate or obtaining or finalizing the random variate. Here you can see this is the method to generate a random variate x uniformly distributed between 1 by 4 and 1. So here we go, as of now according to the acceptance rejection technique or the algorithm, we go for the step 1 where we generate a random number r. So any random number r which is been given, consider the random number it as r. Next go to the step 2. If random number, that is r, which is greater than or equal to 1 by 4, so the value lies between 1 by 4 and 1. So we can accept, that is x is equal to r, and go to the third step and we can stop it. That is, in the third step, if another uniform random variate on 1 by 4 comma 1 is needed, repeat the procedure beginning at step 1. If not, stop it. So if you have been given with only one random variate or random number, first go for the step 1 selecting the random number. Next go to the step 2 to check whether the random number is greater than or equal to 1 divided by 4. If it is true, accept it and go to the step 3, and in the step 3 you stop it. In case if you have been given with another random number, again start with the step 1. Now I'll be explaining why we have this step 2b. Step 2b is, if the random number being given is lesser than 1 by 4, so the random number is been rejected, and directly go to the step 1, which is you are having the new random number. You are not going to the step 3, that is the stop. You go for the next random number. So similarly what happens, all these steps keeps on continuing till you have the random numbers. So as of now, in brief, the acceptance rejection technique is very simple, where you have the algorithm having three steps: step 1, step 2 and step 3. Step 1 is generating the random number, step 2 is for comparing the random number with the any specific value which can be accepted or rejected. Next is the step 3. If now the step 3 is the stopping step. As discussed earlier, now in this slide we are going to use the Poisson distribution. So Poisson distribution random variable are to be used, and we apply the algorithm, that is the acceptance rejection algorithm. So a Poisson random variable capital N with means alpha greater than 0 has PMF P of n is equal to e to the power minus alpha into alpha to the power n whole divided by n factorial, and n is equal to 1, 2, 3 and so on. So here we have capital letter N, which is the number of arrivals from the Poisson process in 1 unit of time, and alpha value, which is the rate. So now according to the algorithm we have three steps: step 1, step 2 and step 3, where the step 1 is for setting the values of n and p value, step 2 is for generating the random numbers or using these present random numbers and calculating the new p value by multiplying the previous p value with the random value. Next step 3 is comparison with the p value and the critical value, that is e to the power minus alpha value. If it is lesser than e to the power minus alpha value, then the random variate and the random number is been accepted and is been highlighted as n is equal to 0. Otherwise, if the value is been rejected, the n value is been increased by 1. Previously, if the n value is 0, then it has been increased by 1 and the n value becomes 1, and you return to the step 2. If the value is been accepted, you stop there in case if random numbers or no more random numbers have been given. If new or more random numbers have been given, start from the beginning, that is step 1. So step 1, step 2 and step 3. Step 1 is for setting the n value and p value. Step 2 is for generating or using the random numbers and calculating the p value. Step 3 is for comparison of the p value with the critical value. If the p value is less than the critical value accepted, move on to again step 1. If the critical value is not met, then reject the value and move on to step 2 to continue with increasing the n value. So for this, for more detail, we have done, or we are going to see another one problem, that is the first problem based on the random variate. So the first problem is generate 3 Poisson variates with means alpha is equal to 0.2 and the random numbers have been already given, that is random numbers are 0.4357, 0.4146, 0.8353, 0.9952 and 0.8004. So you can see here, as of now in the question we have 5 random numbers being given and they have asked for generating the 3 Poisson random variates. So we'll be solving this problem in the next slide. Here is the solution for the first problem, which is based on your acceptance rejection technique. So now, based on your acceptance rejection technique and the question being given, we consider the alpha value and it is the Poisson distribution. So alpha value has been given as 0.02 and we calculate the critical value, that is e to the power minus alpha value. By substituting the alpha value as 0.2, we get it is 0.8187. So we have got the, therefore we have got the critical value, that is e to the power minus alpha value, which is 0.8187. So now we start with the algorithm based on the step 1, step 2 and step 3. So first you can see here we are going for the step 1, that is initializing the values or the variables n and p value. So set n is equal to 0 and p equal to 1. Next we go for the step 2, that is generate r1. R1 is already been generated and the value of R1 is been given in the question, that is 0.4357. We take this R value and we take the P value as 1 and calculate the new P value. So P is equal to P into R1, that is 1 into 0.4357, which is equal to 0.4357. Next we move on to the step 3 for comparison with the critical value. So P value has been given as or obtained as 0.4357 and critical value is 0.8187, which satisfies the condition where P value is lesser than e to the power minus alpha value. So now here you can see it has been accepted or written as accept, and you can see the capital letter N is equal to 0 is been highlighted or it has been present inside a box. So it tells that this random number is been accepted. So in your question totally 5 random numbers have been given. So first random number is been accepted. Next we go for the next random number and we start with the step 1. So step 1 is set n equal to 0 and p equal to 1. Next step 2 is for generating the random number r1 and here we take the r1, that is 0.4146. Previously we have taken the random number as 4357, which has been given in the question. Next random number being given in your question is 0.4146. So we take this number as r1. Now we need to calculate the p value. The p value has been given as 1 and random value is 0.4146. So we calculate the new p value, which is equal to 0.4146. Next we move on to the step 3, that is comparison with the critical value. P is equal to 0.4146 less than or equal to e to the power minus alpha, which is true, and this also is been accepted and the n value is equal to 0 is been highlighted and it has been accepted. Next again we move on to the step 1 by selecting or opting the third random value, and here the step 1 is initializing n value and p value as 1. So set n equal to 0 and p equal to 1. Next step is step 2, where you need to calculate the p value by taking the next random number. The next random number is equal to 0.8353. So p value is equal to 1 and r value is equal to 0.8353. So multiplying we get 0.8353. Next we move on to the third step for comparison or comparing with the critical value. The critical value is 0.8187 and the value obtained is 0.8353. So 0.8353 is greater than 0.8187. So here the critical value has been exceeded and the value is been rejected. So once the value is been rejected, the n value is not been accepted and return to the step 2 by increasing the n value by 1. So previously the n value was been given as 0 or obtained as 0. Now it is been increased by 1 and the n value which is equal to 1. Next we move on to the step 2, where R2 is equal to 0.9952. So the previous random value has been rejected and the next random value is been considered, that is R2 is equal to 0.9952. Now we need to calculate the new p value, which is p is equal to p into r1 into r2. So previously the p value is 0.8353. So 0.8353 into 0.9952. So which gives 0.8313. Now we move on to the step 3, and in the step 3 we consider the p value and the critical value. The p value is been increased or it is been greater than the critical value, so the value is rejected and therefore n equal to 1 is rejected and return to step 2 with increasing the n value. So previous n value is equal to 1 and increase it by 1 and new n value becomes 2. Now start with the step 2 for initializing or using the next random number being given. So the next random number being given is 0.8004. So p is equal to p into r1 into r2 into r3. So the previous p value is p value is 0.8313 and the new random value is 0.8004. If we multiply with this, we get it is 0.6659. Next we move on to the step 3, where we see p is equal to 0.6659 and less than equal to e to the power minus alpha. So this value is been accepted and you can see the capital letter n equal to 2 is been highlighted inside a box. So it clearly tells that the 3 random variate being generated by the Poisson distribution is n equal to 0, n equal to 0, n equal to 2. So as per the question being given, in the question we had totally 5 random numbers. Out of that, first random number, second random number has been accepted, third, fourth is been rejected and the fifth one has been accepted. So acceptance rejection technique gives you the random variates or the Poisson random variates and the representation of the Poisson random variates as n equal to 0, n equal to 0, n equal to 2. So this representation is very much important and it has to be highlighted in your problem. Now we move on to the second problem of Poisson variate. Again, the algorithm being used here is acceptance rejection technique itself. The question is, generate 5 Poisson variates with the mean alpha is equal to 0.25 using acceptance rejection technique, and the random numbers are as follows: 0.073, 0.693, 0.945, 0.739, 0.014 and 0.342. The random numbers have been given here and the alpha value is been given as 0.25. So based on this alpha value, we can calculate the critical value, that is e to the power minus alpha, which is equal to 0.778988. Now we start with the algorithm with step 1, step 2 and step 3. For step 1 is for initializing n value equal to 0 and p value equal to 1. Step 2 is for calculating the p value by multiplying the p value and the random value. Next, step 3 is for comparing the p value obtained by the critical value. If the p value obtained is lesser than the critical value, the number or the value is being accepted. If the p value is greater than critical value, the variate is rejected and the n value is been incremented by 1 and continue with the step 2. So now we'll start solving the problem. Now we can see the step 1 here, where setting the n value equal to 0 and p value equal to 1. Next we go to the step 2, where r1 equal to 0.073 as given in the question. Now calculate the p value by multiplying p into random number, that is 1 into 0.073, which comes to 0.073. Go to the step 3, where it is comparison with the p value and the critical value. By comparing the p value and the critical value, so p value is lesser than the critical value, so which can be accepted, and you can see n equal to 0 is been highlighted inside a box. Next continue with the step 1, that is set n equal to 0 and p equal to 1. Next go to step 2 for considering the second random number, that is r1 equal to 0.693 as per the question. Calculate the p value, p into 1 into random number, which gives us 0.693. Next go to step 3 for comparison with the p value and the critical value. So p value is 0.1 and the p value is 1 and the p value is 0.693 and the critical value is 0.7788, which can be accepted and is been highlighted as n equal to 0. Next again continue with the step 1, where taking n equal to 0 and p equal to 1, and step 2 is having the random number as 0.945 from the question above. Now calculate the p value. So p value equal to 1 multiplied by 0.945. So new p value obtained is 0.945. So after obtaining the p value, go for the step 3 for comparing with the critical value. So p value obtained is 0.945 and the critical value is 0.7788. So p value is greater than the critical value, so here it is been rejected. During this rejection, you go to the step 2 by incrementing the n value to 1. Previously n value was 0 and incremented by 1, it becomes n equal to 1. Go to step 2 by considering the next random number, that is 0.739, and calculate the new p value. So previous p value was 0.945 and new p value has to be calculated by multiplying with the new random number. So it will be 0.945 multiplied by 0.739, which comes as 0.6983. So now we need to go to the step 3, where we compare the value with the critical value. So the value p value is 0.6283 and the critical value is 0.7788, which is accepted and is been highlighted as n equal to 1. And now go to the step 1, it is setting n equal to 0 and p equal to 1. Step 2, that is r1, that is 0.014. So p value is 1 and r value is 0.14. So step 3 is for comparing the p value and the critical value. So p value is lesser than the critical value and the value is been accepted and is been highlighted as n equal to 0 at the bottom inside a box. Now the problem still is not being completed because another one random number has to be solved, and that will be done in the next slide. This is the continuation of the previous problem, where you can see step 1 is setting n equal to 0 and p equal to 1, and step 2 equal to r1 equal to 0.342. Now p value is 1 and r1 value is 0.342. Multiplying it, we get 0.342, and we go to the step 3 for comparison with the critical value. During this comparison, the critical value is greater than the p value, so which will be accepted and highlighted as n equal to 0. So therefore the problem has been solved and the final solution has been written as the generated Poisson variates are n equal to 0, n equal to 0, comma n equal to 1, comma n equal to 0, comma n equal to 0. So this is the random variate which tells the acceptance rejection technique. Next we move on to the last problem, that is the third problem, again based on the acceptance rejection technique itself. The question is, buses arrive at the bus stop according to Poisson process with mean of 1 bus per 15 minutes. Generate a random variate n which represents the number of arriving buses during 1 hour time slot using the random numbers 0.5, 0.4357, 0.4146, 0.8353, 0.9952, 0.8004, 0.7945 and 0.1530. So here this is the problem which is been related to your Poisson distribution itself, where the buses or the arrival of the buses has been taken and the bus arrives at 15 minutes in a hour. So here we require the alpha value, but we need to obtain the alpha value. And how do we obtain the alpha value? We obtain this alpha value based on the arrival of the bus, that is the arrival of the bus rate. Bus rate is the buses arrive at 15 minutes per hour. So totally 4 buses are arriving in 1 hour. So therefore alpha is equal to 4, and we obtain e to the power minus alpha is equal to e to the power minus 4, which is 0.0183. So we have got the critical value as 0.0183. This is obtained because of the alpha value, which is 4. Once again I'll repeat how we got this value, that is alpha is equal to 4, that is one bus arrives every 15 minutes. So in a hour totally we have 60 minutes. So 60 divided by 15 we get 4. So totally the alpha value which has been obtained for this Poisson process or for this question is 4. Now we calculate the critical value e to the power minus alpha, which comes as 0.0183. So we have obtained the alpha value and we have obtained the critical value. Now we start solving the problem based on the acceptance rejection technique algorithm. Go to the step 1, set n equal to 0 and p equal to 1. Next go to the step 2, where you consider the random number as 0.4357. Multiply this random number with the p value, that is 1. So 1 into the random number, which gives 0.4357. Now we go for the step 3 for comparison of the p value and the critical value. Here what happens is p value is greater than the critical value, so the value has been rejected and the n value has been incremented or increased by 1. So according to the problem, previously the n value was 0 and has been incremented by 1 and the n value becomes 1. And again go back to step 2. In step 2 we consider the next random number, that is equivalent to 0.4146, and now we need to calculate the new p value. So the older p value is equal to 0.4357 and the new p value will be multiplied with the older p value, so that is p is equal to p into new random number. So it is 0.4357 into 0.4146, we get it as 0.1806. Now we go to the step 3 for comparison with the critical value and the p value. So the p value obtained is greater than the critical value, hence the acceptance rejection technique clearly tells that this has to be rejected, and n value equal to 1 is been rejected. And moving on to step 2 by incrementing the n value to 2 or incrementing the n value by 1. So what happens, previous n value is equal to 1 and new n value becomes 2. Now we move on to step 2, where next random number is 0.8353, and based on this random number we are going to calculate the new p value, and the previous p value what we obtained is 0.1806 is been multiplied with 0.8353, which comes as 0.1509. Now in the step 3 again we compare the p value and the critical value. So the p value is again greater than the critical value, hence the value, that is n equal to 2, is been rejected and incremented by 1, which becomes n equal to 3, and continues to the next step, that is step 2, and the step 2 procedure is been done in the next slide and it will be explained in the next slide. Here you can see after the increment of n value, so the n value has become as 3, and the continuation of step 2. So step 2 and taking the next random number being given in the question, that is 0.9952, and calculating the new p value. So older p value multiplied by new random number, which is 0.9952, is comes as 0.1502. Now again we go for the step 3, where comparing the p value with the critical value. P value is 0.1502 and critical value is lesser than the p value. So here it clearly tells again the value is been rejected, that is n value has been rejected, and the n value is been incremented by 1. So previous n value was 3 and it has become 4, and continue to the step 4. Now continue to the step 2. Now in step 2, take the next random number, that is 0.8004. Now we need to calculate the new p value. So the older p value is 0.1502, multiply it with the new random number, that is 0.8004, which we obtain it as 0.1201. Now move on to step 3 for comparison with the p value and the critical value. Here the p value is again greater than the critical value, which clearly tells it has to be rejected, and n equal to 4 is rejected and returned to step 4 by incrementing the n value by 1. So what happens, the previous n value was 4 and the n value has become as 5 now. Now you go to the step 2, and in step 2 consider the next random number, that is r6 is equal to 0.7945, and calculate the new p value. So new p value is been obtained by multiplying the older p value into the new random number. So multiplying, we get the value as 0.0955. Now go to the step 3, and in the step 3 you can see p value is greater than the critical value. So again n equal to 5 is also been rejected, and return to the step 2 with incrementing n value to 1, and n value becomes 6. Now go to step 2 where r7 is equal to 0.1530, and calculate the new p value. New p value is been obtained by multiplying the older p value with the random number or the new random number, which comes in as 0.0146, and the p value is 0.0146. Now go to the step 3, and in step 3 compare the p value with the critical value. Now you can see the p value is lesser than the critical value, and which is been accepted, and you can see n equal to 6 is accepted and is been highlighted. So as of now from the problem, the generated random variate is n equal to 6. Thank you.